Here are the solutions to homework set number 2 for ECE 341. In this homework, we're looking at combinatorics in card games. The first problem is bridge. In bridge, you're dealt 13 cards from a standard 52 card deck. Problem 1, how many different ways can you do that? Well, that would be combinatorics. 52 choose 13. And for those who use with HP calculators, that's under probability. Under second probability, that's combinatorics permutations. So if we do 52, enter 13, combinations, 635 billion. Different ways of doing that. What's the probability of being dealt 7 cards of one suit? Well, to do that, what you do is I've got 4 suits, pick one. Of the 13 cards in that suit, pick 7 of them. Of the 39 remaining cards, pick 6. So again, with an HP, that would be, let's do 4, enter 1, probability combinations. 13, choose 7, multiply. And then 39, choose 6, multiply. 22 billion ways of doing that. The probability then is divided by 52, choose 13. 3.5% chance of being dealt 7 cards of one suit. Not terribly likely, but it does happen. Problem 2. What's the chance of having only 2 face cards in your entire hand? Well, there are 16 face cards, Jack, Queen, King, Ace. 4 times 4 suits gives you 16. Of the 16 face cards in the deck, choose 2 of them. Of the 36 remaining cards, choose 11. And again, you can do that with your calculator. That would be 16, choose 2. 36, choose 11. Multiply together, 72 billion ways of doing that. Divided by 52, choose 13. 11% chance that you only have 2 face cards in your hand. Problem 3. Check your answers with the Monte Carlo simulation. So here, what I did is I wrote a program. I'm going to deal out cards. That's what this does. I'm going to generate 52 random numbers, then sort them. The second one is what I want. That gives you the order of the sort. Pick out the first 13 cards. And what that'll look like is this. First, deal out 52 cards. So this is what my random numbers look like. It generated 52 random numbers. When I sort them, the first number is the sorted data, which I don't care about. The second number is the card. So the 32nd card in the deck is on top of the deck. The 40th card in the deck is the second one, 22nd card, and so on. To get the value, my hand are the first 13 cards in the deck. So there's my bridge hand. To see what the values are, take the mod of hand minus 1, because it starts at 1, going 0 on up. Take that mod 13, so it goes 0 to 12, 0 to 12, 0 to 12, plus 1 gives you 1 to 13, 1 to 13. There's the cards. So there's the 6, Ace, 9, 8, 9, 6, 3, 3, Jack, 4, Queen. And to get the suit, divide by 13 gives you numbers and round up. So here's the suits. Hearts, spades, diamonds, hearts, hearts, clubs, clubs, diamonds, diamonds. Once I have that, I can sit there and count. How many cards in my hand are suit number 1. So, oops. So MATLAB can sit there and say, is suit equal to 1? I have 3 clubs, 2 diamonds, 5 hearts, and 3 spades. I will then sort in descending order so that the most frequent comes first. If the most frequent suit has 7 of them, I've got 7 in that suit. Add 1. Now go back to the values. Which I don't care about in this problem, so we'll ignore that. I will then count how many times I had 7 of a suit. In terms of face cards, if the value is 1, meaning an ace, or the value is more than 10, jack, queen, king, I'll increment the second counter. And I had 11,000 hands with 2 face cards. Now, by doing that, here's what I calculated. The odds should be 3.5%, meaning for 100,000 hands, I should get 3526 hands that have 7 cards in it. Running the Monte Carlo, I got 3627, 3470, 3517. Again, not exactly the same, that's Monte Carlo, but same ballpark, meaning I probably did it right. For 2 face cards, I calculated 11% chance, meaning I should get 11,000 hands out of 100,000 with 2 face cards. With Monte Carlo, I got 11,298, 11,437, 11,367. Again, fairly close. That doesn't prove it, but that makes me suspicious my calculations were correct. Monte Carlo's giving similar answers. Not exactly the same. That's the problem with Monte Carlo, but fairly close. So that kind of checks my calculations. Problem 4. Suppose I play poker where I'm dealt 6 cards. Take the best 5. What's the chance of getting 2 pair? And the reason for doing 6 cards is on the web, 5-card poker's been analyzed to death. Not that many sites have 6-card poker, so here I actually have to do some calculations. For 6-card poker, I want to have the hand of XX, YY, AB, and actually 2 combinations. It can be this combination or this one. I've actually got 3 pair. Take the best 5, it's actually 2 pair. From enumeration, I know what the answer is. It should be 20,358,520. So if I do the calculations right, I should get the same answer. Well, to get this combination, I have 13 face values. Pick 2 for x and y. 13, choose 2. Of the 4 x's, choose 2. Of the 4 y's, choose 2. That's this branch. Now for the AB's, there are 11 other values. Pick 2. Of the 4 A's, pick 1. 4 B's, pick 1. Multiply it all out, I get 2.4 million. Okay. The second case, 3 triples. I've got 13 cards, choose 3 for x, y, and z. Of the 4 x's, choose 2. 4 y's, choose 2. 4 z's, choose 2. So there's 61,000 different ways of getting this combination. Add the 2 together, I get 2.5, 2,532,816. Go back to combinatorics, that was exactly the same answer we had before. So another way of doing it, correction, by using enumeration, that's the same answer I had before. But this didn't take me 10 minutes. Actually, it took me longer because I had to figure it out right. But if you do it right, it should take you less than 10 minutes. That's the beauty of combinatorics. I don't have to sit there and go through every permutation. Problem 5. Chance of being dealt 1 pair. Now, what 1 pair would be, I've got some card value X, I've got 2 of them, and 4 other cards that do not match. From enumeration, I know what the answer is. 9,884,160. Can I get the same answer using combinatorics? Well, there are 13 cards in the deck. Pick 1 for X. Of the 4 X's, choose 2. Now for the remaining 4, there are 12 other values. Pick 4. Of the 4 A's, pick 1. 4 B's pick 1, 4 C's pick 1, 4 D's pick 1. Multiply it all out, I get exactly the same answer, 9,884,160, found using combinatorics. Ability. Problem 6 is check your answer using Monte Carlo. We'll talk about that in just a sec. But here's what I got using enumeration. Here's what I got using combinatorics, and these two should be exactly the same. With Monte Carlo, I ran a simulation with 100,000 hands, and 12.3%, 12.4%, 12.6%, about the same. The hands had 2 pair, 48.6, 48.5, 48.4, about the same, and 1 pair. So that kind of confirms that the calculations are close, and also confirms my Monte Carlo simulation is right. Probably right. Here's what the Monte Carlo looks like. Same as before, I'm going to take a 52-card deck, now pull out 6 cards rather than 13. Find the value of each card, find the suit, and then count how many aces, how many 2s, how many 3s, how many 4s, sort in descending order. So the most frequent card, if its frequency is 2, and the second most frequent card is also 2, I've got 2 pair. If the most frequent card is a 2, and the second most frequent is less than 2, I have 1 pair. Increment the counters, and when you're done, display how many hands I had of 2 pair, how many of 1 pair, and that should be your 12%, 48%. So that is homework set number 2 for ECE 341. The point behind combinatorics is I can calculate the number of ways I can get a hand, like 4 of a kind, 5 of a kind. I don't have to go through enumeration. Enumeration always works, but it can take a lot of time. With combinatorics, I can do things that I really can't do with enumeration. Again, homework set number 2 for 341.